Welcome to the homework help video class. Pre-calculus students, hope you're doing well. This is a difficult assignment, so I'm sure you've went through boxes of tissues and sweated a lot of sweat over these problems. Hang in there. That's what this help video is all about. I was talking to a parent the other day, not any of you all's parents, but a mom and a dad who homeschool their children. They're young. They're about 10, 8, and 4 and 2 or something like that. But anyways, and I was telling them about the class and how I really do try to give you good notes. I try to keep the video short. And then we were talking about a curriculum called Saxon, which personally I'm not a huge fan of. I feel like their homework is just like the examples in the book. And I was telling these parents how I like the homework to be more challenging than the examples that I give for a couple of reasons. First of all, it makes you think on your own. Secondly, it encourages you to do the homework. You know, if you don't do the homework, you're going to be behind. You've got to do the homework. And then lastly, it makes you struggle. I mean, you've got to fight, you've got to push, and you've got to work hard. And I think that's always good for you. So I'm sure that you guys disagree, but that's okay. We'll just agree to disagree. Okay, grab your homework. You should have started this. If you didn't, that's your business. I gave you my recommendation. I hope you're listening to me. I hope you'll call me or email me with questions. This will be the hardest assignment you've done. If you've started it already like I recommended that you do, you saw there are some tough ones in here. The hardest one is number 23. The second hardest one would then be, I don't have it in front of me. I believe it's number 33. But we'll get to those here in a little bit. Contain your excitement. So let's go ahead and get started. Let's start off with number 17. Your book should be open to page 454. I'm going to read number 17. You can follow along. An aerial photographer who photographs farm properties for a real estate company has determined that the best photo is taken at a height of approximately 475 feet and a distance of 850 feet from the farmhouse. What is the angle of depression from the plane to the house? Angle of depression from the plane to the house. Okay, now let's go ahead and get started. I can explain this well. Please, I'm not bragging, but please listen to me and I can help you. Okay, here we go. First of all, you do see the picture in your book, and I have it right there in front of you. If I can get my pen to work here. There we go. I was clicking on the wrong thing. All right, I'm going to go ahead and try to trace over this triangle. So there's the triangle they've given us, okay? Now I'm going to go ahead and grab this picture and pull it out of the way. So all that I've done is I have put and that's not what I wanted there. I want that. All that I did is I pulled the triangle out of the way, or the picture out of the way, and then there's the rest of it coming across there. Now let's go ahead and draw some other things in here relatively quickly. There's the angle of depression. You can see that in your book. There's theta. This is 850 feet, and this is 475 feet, and this is down here the angle of elevation. Now, here we go. I'm going to go ahead and delete this. It's no longer necessary. I wanted the picture there so you could see where I got my triangle from. Now, what they have asked you to find is this. Are you ready? Please listen, and I can help you. They have asked you to find the angle of depression. Now, students, if they had asked you to find the angle of elevation, that would be this angle down here. Remember, a horizontal line, and you rotate upward. That would be an angle of elevation. They have asked you to find an angle of depression. That means you draw a horizontal line, which the book did for you already, and you rotate down until it hits this line right here. So we're looking for this angle right here that I'm circling over and over and over 100 times. That's the angle you're looking for. Now, it doesn't take an aeronautical engineer to figure this out. Would you please listen? Please listen, students. Here's a horizontal line, and here is a vertical line. That means I have a right angle right here. Do you see that? You should see that. That means I have a right angle. Now, that means that this angle here with one dot and this angle here with two dots should add up to 90 degrees. This angle here with one dot and this angle here with two dots should add up to 90 degrees. So here's my plan of attack. Are you ready? See how I have a right triangle right here? Right here. Here's my right triangle. Do y'all see that? Well, if I can find this angle right here, we'll call it X. If I can find that angle there, And then remember how these two angles here have to add up to 90. If I can find this angle here and then subtract from 90, that will give me this angle up here, because these two angles add together equal 90 degrees. Now we should know how to find angles in a triangle. Now watch this. Here's the angle I'm trying to find. Got it? So go straight across. This is my opposite side. Here's my right angle. Go straight across. This is my hypotenuse. And this here is my adjacent. Now, please watch this. I'm dealing with, I don't want this side over here. I'm trying to find an angle. So I need two known sides to find an angle. So I'm dealing with an adjacent side, and I'm dealing with a hypotenuse side. So adjacent and hypotenuse. What trig function has adjacent and hypotenuse? SOHCAHTOA, cosine does. So I can say the cosine of x equals adjacent over hypotenuse. Do you see that? Now, I've taught you that anytime you're looking for an angle, you hit this in your calculator, the second button, and then cosine, and up should pop on your screen this with the parentheses, and then you type in 475 divided by 850, then close your parentheses and hit enter. And when you hit enter, you will get x equals 56 degrees. So now I know this angle right here inside the triangle is 56 degrees. So how do I find theta, this angle of depression right here? Well, remember, these two angles together had to add up to 90. So if I take 90 and subtract 56, I will get 34 degrees. And that makes sense, doesn't it? Because if I put 34 degrees here, 34 plus 56 do add up to 90. So this is my answer right here. There's my angle of depression right there, 34 degrees. Moving on to number 19. Let me get a drink of water here. Okay, number 19. Each spring, Brian uses his vacation time to get his lake property ready for the summer. He wants to run a new safety line from point B to the corner of the raft. The current safety line, which runs perpendicular to the shore to point A, is 40 feet long. You can see that in the diagram. He estimates the angle from B to the corner of the raft is 50 degrees. Approximately how much rope does he need if he wants 5 feet of extra rope at one end and 5 feet of extra rope at the other end? Okay, I paraphrase there, but you get the idea. Now, I'm going to do what I did before, and I hope that you don't mind this. I'm going to trace the triangle. And then I'm going to pull the picture out of the way. All right, very good. Now, let's see. I've got angle B here, angle A here. This is your raft out here somewhere. I'm going to put a little raft right here, I guess, just for the artistic purpose. This would be 50 degrees right here, and this will be 40 feet. All right, so now that you see where all my information came from, let's delete this picture. All right, now, approximately how much rope does he need for the new safety line? Well, the new safety line is running from here. Let me get my pen ready. Is running from here to here. Because remember how I know that? The old safety line was 40 feet, so I know it's not this line here. That's the old safety line. The new safety line is this one. So I'm going to call this X. Now, I have a right triangle. I have an angle. Let's go straight across. We'll call this our opposite side. Here's my right angle. Go straight across. We'll call this the hypotenuse side. And the last side is my adjacent side. Now, students, I am looking for this side here, the new safety line. So I'm looking for the hypotenuse. So I know whatever trig function I choose, it must have the hypotenuse. That rules out tangent. Tangent's opposite over adjacent. So I'm going to use sine or cosine. Well, I would not want to use cosine. Cosine is adjacent over hypotenuse. Look, I would have two unknowns. Cosine of 50 degrees is adjacent over hypotenuse. I don't want two unknowns. That's not going to help me. So the only thing left would be sine of 50 equals opposite over hypotenuse. Now, in the last problem, we were missing an angle, right? angle X. Right here, I'm drawing an arrow to it. And whenever you're missing an angle, that's when you use your second cosine button. We're not missing an angle. The angle is 50 degrees right here in front of us. Whenever you're missing a piece over here, what I've told you to do is multiply both sides by the bottom of the fraction. So multiply the right side by h, the left side by h, and you're left with h sine 50 equals 40, because these cancel. Now look, if h is multiplying sine, if I want to get h by itself, it makes total sense to me that I would divide both sides by the sine of 50. So there we go. These cancel, and now I know what h equals. H equals 40 divided by sine of 50. Now, with your calculator, you would simply type in 40, then hit divide, then hit sine, and when you hit sine, this should pop up right here, sine with the parentheses, and then 50, and then close your parentheses and hit enter. And if you do this correctly, for number 19, you should get 60, oh no, you should not, excuse me, that's wrong. You should get 52.2 feet. Now, students, that's not the answer. It's not, Mr. Earhart. No. Look at the very last sentence of the problem. It says he wants 5 extra feet of rope at each end. At each end. So if your rope is 52.2, and then you tack on 5 more feet here, and you tack on 5 more feet here, you're tacking on 10 feet. So the answer to the final answer to the problem would not be 52.2, it would be 62.2 feet. And that is how the problem is done. All right, moving on to number 21. I will read as you follow along. A supervisor must train a new team of loggers to estimate the heights of trees. As an example, she walks off 40 feet from the base of a tree and estimates the angle of elevation to the tree's peak to be 70 degrees. How tall is the tree? All right, now here we go. Back to my tracing abilities. This picture is in your book. So I'm going to draw a line like this, and then we're going to go up like this, and then down like this. Now I'm going to pull the picture out of the way, and let's fill some things in. Here's my right angle. This is 70 degrees. This is 40 feet. And you know what they're trying to get you to find, students? The height of the tree. Would not the height of the tree be this right here? Unless the tree's leaning really badly sideways, yes, this is the height of the tree. So let's get rid of this. No need for that picture anymore. And now let's go ahead and find our missing side. I'm going to call it X. Now, we know an angle. Here it is. We go straight across. This is my opposite side. This is my hypotenuse. And this is my adjacent side. Now, look, students, you're welcome to use opposite and hypotenuse if you want. That would be sine. But that's two unknowns, an x and a whatever you want to call it over. That's not going to help. I need to use opposite for sure, because that's the side I'm looking for. And the other side I want to use is adjacent, because that's a known side. I know it's 40. So, what trig function uses opposite and adjacent? Well, SOHCAHTOA. TOA. Tangent of 70 equals opposite over adjacent. Well, we're not missing an angle. We're missing a piece to the fraction. So we multiply both sides by the bottom. In this case, it would be 40. So multiply both sides by 40. Over here, these would cancel, leaving you with x. Over here, I'm left with 40 tangent 70. That means 40 times tangent of 70. By the way, if you're missing some of these, check your calculator and make sure you're in degree mode. But anyways, with your screen, you type this in just like this. Type in 40, then hit tangent, and then 70, and then enter. And you should get the correct answer. You should get 110 feet. We're dealing with feet because it was 40 feet here. So how tall is that tree right there? Well, it's 110 feet tall. Now this problem here is, number 23, is truly amazing. Let me get a drink of water here. And I want to warn you, this is going to take probably 2 or 3 pages, I would think. Not notebook paper, but pages of this MimioPad program. And I want to also tell you, I probably wouldn't give you one of these on the test. I might. But I won't give you a ton of them. And this is a really tough problem, so please do not be discouraged if you're completely lost. This problem is going to involve a right triangle drawn within a right triangle. it's going to involve writing two equations, or writing one equation with two unknowns and one equation with one unknown, and then substituting one equation into another equation. It's very, very, very difficult. So all together, take a deep breath, and let's work through this together, okay? Now, the first thing I recommend is we probably should read the problem, okay? The Golden Gate Bridge has two main towers of equal height that support two main cables. A visitor on a tour ship who has way too much free time is passing through the San Francisco Bay. He views the top of one of the towers and estimates the angle of elevation to be 30. After the ship moves 670 feet closer, he estimates the angle of elevation to be 50 degrees. This guy's really good at estimating. Approximate the height of the tower to the nearest foot. So, if it's okay with you guys, or if it's not okay with you guys, we're going to go ahead and trace this triangle. So we should have this here, coming straight down. Whoa, wow, holy cow, it's a straight line. And then straight over to here. And then straight down to here. Here we go. And then we'll draw this little line right there. Cool. Very cool. I think we actually got it. Let's pull the picture out of the way. And by the way, I'd encourage you to do this in your book too. Mr. Earhart, I can't do what you're doing. Well, you can at least copy the triangle without all the bridges and the water and the clouds and the cables. Just get all that distracting stuff out of the way. All right. Now fill everything in correctly. We see this is our X right here. The problem says that's what we're trying to find is the height of the bridge. This is 50 degrees here. And this is 30 degrees here. And from here to here, we have a measurement of 670 feet. And I think that's just about all they give us. I'm pretty sure. So let's do this, delete. And you know what? As scared as I am, we're ready to roll. So let's see if we can't tackle this thing. Now, the first thing I want to show you is we have two right triangles. Okay? Would you please watch this, students? First of all, we have this right triangle right here. And I did that on purpose, and now I want to pull it. Oh, I want to pull it out of there. Okay? So there's that right triangle. Okay? Now here's my next right triangle right here. And I want to pull that one down here. Do you see what I did there? Again, I'm not asking you or telling you, you should have known how to do this. No, 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 no. This is not easy. I get that. But I want you to at least understand what I'm saying. So we know this is 50 degrees. We know this is X going up and down. This is X. Remember, this is the same height. This line here is the same as this line here. They just overlap up here. We know this whole line all the way across. Oh, no, I'm sorry. That is not true. We know from about here to here is 670 feet. We've got that there to there. And we know this is 30 degrees. So I've really done nothing. Are you impressed? I've done nothing. I've done nothing except just simply copy everything, kind of break it down so you can see it. Okay? Now, I'm going to call this right here Y. So that means from here, let me back up here. I don't like that. Put a point here. That means from here to here, we're going to call that Y. Okay? You say, Mr. Earhart, how do you know that? Because again, guys, remember, if I pick this triangle up right here and I put it right there, see how it fits in there? I mean, it's not perfect. Obviously, I'm not a perfect drawer, but you get the idea. So that's why I can state those things. Now, there we go. Okay, now, this is going to be really hard to do. This is not going to be easy at all. I would like to first of all recommend that we start off by looking at this. I told you it's going to take up 2, 3, 4 pages and a long time. Okay, so understand that. Be ready for that, but at least I'm not giving you any notes today. So that's the good news. All right, let me reach up here. All right, let's grab this. Let's pull there. Now, I would like to recommend, first of all, we do a formula like this. Are you ready? A formula that uses, here's my angle, right here, that uses, here's my angle, opposite and adjacent. Now watch. So I would say tangent of 30 equals opposite over, oh, what is this whole side right here? Well, guys, come on. Would it not be y plus 670? Come on, think about that. Look, if I gave you a line and I said, hey, this is 5 feet, and from here to here, this is 10 feet. What's the length of the whole line? You would say, oh, 15, 5 plus 10. Well, why can't we do the same thing with this, even though it's a y? If from here to here is 670, and from here to here is y, we can say the whole length of this bottom triangle is y plus 670. Now, the problem with that is I have two unknowns. You have preached to us all for the past 2 days, we don't want two unknowns. Usually you don't, but sometimes you have to. So if you have to, you have to, okay? Not a whole lot we can do with that. So do you see, I'm not asking would have you thought to have done this on your own. I know you wouldn't have, but at least you understand where this came from. Hopefully you do. Now, let's go ahead and let's copy this triangle right here, and let's grab it. Let's drag it over here, and now let's highlight it, and let's pull it over here. Now, I would like you to go ahead and write, remember your final goal is to find x. Don't forget that. If you'll look at the problem, it says, what's the height of the bridge, the tower and the bridge? So our final goal is to find x. Okay? Now, I'd like you to write a function, again, using this angle, 50, opposite and adjacent. So I'd like you to write a trig function there. So from this angle, I get tangent of 50 equals opposite over adjacent, x over y. So again, I'm not asking you to teach the class. I'm not asking, could have you done this on your own? But hopefully you might still be lost and say, I don't see why he's doing this. Fine. But do you at least understand where these formulas are coming from and how I could take a triangle like this and split it up into two triangles and then write two trig functions? Now, here's what I would like to do next. Next, I would like to take these two trig functions and see if we can't use those to solve this problem. So, let's first of all take this one and we'll slide it right over here, and this one and slide it right, oh, and we'll slide it up here. Now, watch this carefully. I can make some substitutions here. What I decided to do was this. Please watch carefully what I do. I'm going to multiply both sides by y because I don't like having this fraction. Just watch what I do. Watch. Multiply by y, multiply by y. Now, when I do that, these y's cancel, and I'm left with x. Over here, I'm left with y tangent 50. Well, big deal, Mr. Earhart. That's a huge deal. What does x say? What does x equal? Say it with me. You ready? Say it. Y tangent 50. Let's say it again. What does x equal? Say it with me. Y tangent 50. So if y tangent of 50 equals what? X? Then can I not pick this up and put it in for x? Well, sure I can. Why not? It equals x. It's the same thing as x. So where this x is right here, I'm now going to put y tangent of 50. And you're probably saying why, and I'm going to show you why right now. Watch what happens. Y tangent of 30 equals, did I say y tangent of 30? Wow. Tangent of 30 equals y tangent of 50 over y plus 670. Now, why is that a huge deal? Well, thanks for asking. I'm glad you asked that question. It's a huge deal because look what I have now. I have, and of course I'm erasing all this. You should have this in your notes. Please do not erase this. I'm just trying to create more space here like a soccer player and get some more room to work with here, okay? All right, now, look what I have. I have only one unknown, a y and a y. Now, I can work with this. It's going to take a lot of work, but at least I have one unknown. Now, you should know what to do. I've taught you we don't like fractions, so we're going to multiply both sides by whatever the bottom is. Now, what I shouldn't have done is I should have left this in the middle, so hopefully you're not getting dizzy from all the moving I'm doing. All right, so I'm going to multiply this side by y plus 670, but I'm also going to multiply this side over here by y plus 670. Now, on the right side, obviously those cancel, and you're left with y tangent 50. Over here, I'm going to take my tangent of 30 times y and also my tangent of 30 times 670. So tangent of 30 times y would be y tangent 30, and then tangent of 30 times 670 would be 670. Please don't multiply the 30 and the 670. That would not be correct. There we go. Now we're doing okay, guys. I mean, I'm sure you're like, what? And I'm not saying I'd give you any of these on a test or a quiz. I might not. I'm just saying learn to love a challenge. This is the hardest one in the homework, and once we're done with this, we'll get back to flying through the easier ones. And there's one more that's not as hard as this. It's average hard, and the rest are really pretty simple the rest of the way through. Now, this is looking pretty good. Are we not solving for y? The answer is, well, actually, our final goal is to find x. We've got to solve for y first. So let's get all of our y terms on one side. So watch what I do. Y tangent of 30, and then bring this whole term over here, and that would give you, it's a positive. The whole term is positive, so when I bring it over, it becomes negative y tangent 50 equals, now bring this whole positive term over to this side over here, and when you do, it's going to become negative. Why are you moving that, Mr. Earhart? Because there's no y with it. If there's no y with it, I don't want it on the side with y's. And it's kind of funny, now that I've done this, I really could have done it faster, couldn't have I? I really just could have brought this term over here and add all the y's on one side, but your teacher's getting a little old and senile. So, all right, we brought the positive 670 tangent 30 over, made it negative. Now, what we want to do is we want to solve for y. So I notice this term has a y. I notice this term has a y. So we didn't learn factoring just for the fun of it. We're going to use it. Let's pull a y out. So if I pull a y out of both terms, I'm left with tangent 30 minus tangent 50 equals negative 670 tangent 30. Wow, this is a killer. Now, students, with your calculator real quick, would you do me a favor? Would you please type in tangent of 30 minus tangent of 50 just like that? Let's break that down to a number. If you do that correctly, you're going to get negative 0.6144. So now I have negative 0.6144y equals, okay? Now, well, Mr. Earhart, why didn't you put the y out front here? I guess you could. That's really weird. I mean, it's not y multiplying, it's y times this. So when you type all that in, let's just go ahead and put negative 0.6144y. Now over here, I would have negative 670. I'm typing it in right now, tangent of 30. And that would give me negative 386.8247 rounded. And now, students, let me go ahead and get a new page up here and then go back. Look, students, I think you can see now, just divide both sides by negative 0.6144, and we really should be doing pretty well. So if you divide both sides by negative 0.6144, you should get, well, a negative 386.8247 divided by negative 0.6144, you should get 630. I rounded that, of course, obviously, 630 feet. Now, all right, now watch. Let's go way back to our original drawing so we can see what y stood for. There it is right there. Y is this figure right here. That's not what we're looking for. Y is this right here. We're looking for x. But look right here. Hey, go back to where you had this function right here. Right? Do I not know what y equals? Let's go down 2 pages. What does y equal? 630. So go back over here. Now where y is, remember this function we had earlier, this equation? Tangent of 50 equals x over, and now where the y is, I can go ahead and put 670. And now I can finally solve for x. I know you feel like you've already graduated from high school. It's been so long since we started this problem, but let's go ahead and multiply this side by 670. Go ahead and multiply this side times 670, and these 670s cancel. You're left with x, and over here you're left with 670 tangent of 50. And now go ahead and type that into your calculator, 670 tangent of 50, and you will get, cheers please, 750 feet equals x. So you did it. So now you know how tall that bridge tower is, and I know you're so excited about that. 750 feet. That, whether you like it or not, is a good problem. That makes you think. All right, number 25. They don't give us a picture, which I love that. I want you guys to start drawing your own pictures. A regular pentagon is inscribed inside of a circle. So let's see if I can cheat. Let's see if they have a pentagon. Oh, they do. Sweet. All right, so there's my pentagon. Now let's see if I can cheat a little more. Ah, good. How does this circle thing work? Not like that, that's for sure. All right, let's do that. Let's try it here. Is that what they do? Not hardly. You know, I think I'm just going to pick it up and try to move it. I'm talking to myself. Ooh. Wow, not good. All right, well, let's figure this out real quick. You guys are enjoying laughing at me, I'm sure. Okay, well, guess what? I'm officially done, so no more entertainment. You can't laugh at me anymore. All right, let's try this shape recognition. Not too bad. I've definitely seen worse. Maybe I haven't, but anyways. All right. Well, you're going to have to pretend that thing is on the inside. That's a little better. All right. There we go. I don't like to mess things up, so hopefully that will help. All right. I'm definitely leaving well enough alone. Now, students, here we go. There's our problem. Now, it says you have a regular pentagon, a five-sided figure inscribed in a circle. The radius is 15.8. So I'm going to go ahead and draw the radius. It'll be right here in the middle. And I'm going to draw this here to there. And then draw this one here like that. Do you see what I've done? Okay. Now, think about this very carefully. All right. Wish I could turn this thing. That's okay. I do not necessarily have a right triangle, so you cannot assume you have a right triangle. All right. You have a triangle that goes like this and like that. And then a red line that comes down like that. All right. But one thing we do know is we have 15.8 here and 15.8 here. Okay. Do you see that, guys? Let's go over it again. It says we have a pentagon inside of a circle, and the radius, that means from the inside of the circle to the edge of the circle, which would be the corner of the pentagon, is 15.2. So I know I have a triangle that looks like this. Now what I would like to do is very quickly make this a little bigger and turn it so we can see it a little better. I think that will help. All right. And we're talking. And now let's rotate this thing. There we go. I think that'll make it a little easier. Maybe not a whole lot easier, but a little easier. Okay, so I know this side here is 15.8, and I know this side here is 15.8, and we're going to call this side here X, okay? So that means this red side right here is X. Now watch what I can do, students. I can drop down a right angle right here, okay? Do you see that? This is not very easy, but we can do this, okay? Now, if I went ahead and drew a bunch of triangles inside the pentagon, now watch this. How many angles do I have in the middle? 1, 2, 3, 4, 5. 5 angles in the middle. Now hold it. When you go in a complete circle, isn't that 360 degrees? Whenever you see a guy jump and do a complete circle and dunk the basketball, they call it a 360 dunk. So, I've got 5 angles, and I know all 5 of these angles add together have to equal 360. So if I take 360 and divide it by 5, I get 72. So I know each one of these middle angles is 72. Okay, Mr. Earhart, why are you doing that? Well, I'm glad you asked. Think about it. If this angle right here is 72 and I drop this dotted line straight down, does it not cut 72 right in half? The answer is yes, it does. So I can put 36 degrees right here. Now that's a big deal, guys. That's a huge deal, all right? I can now find this little side right here. We'll call it Y. I've got a right triangle. I'm going to highlight it in red. Here's my right triangle. Comes down, comes over, comes down. There's my right triangle. There's my right angle. I've got an angle right here, 36 degrees. I've got opposite and hypotenuse. Opposite and hypotenuse. What would that be? Sine. So sine of 36 degrees equals opposite over hypotenuse. Now, if we multiply both sides by 15.8, we would have 15.8 sine 36 degrees equals y. And now, I have most of these worked out already. This one here I did not, so I apologize. Most of these I have already worked out and done on paper. 15.8 sine of 36 would give me 9.3. So y is 9.3. Got it? Now hold it. That's this little side here, 9.3. So if from here to here is 9.3, then we know from here to here, because I brought it down and cut it in half, will be 9.3. So in blue right here, what is the length of this whole line right here? 18.6. 9.3 plus 9.3. So that means this x right here, this line right here, this blue line right here, is 18.6. 18.6, this blue line. Now the direction said to find the perimeter of the pentagon. Now if this side's 18.6, and this side's 18.6, and this side's 18.6, and this side is, and this side is, that's 5 sides. So I can just simply take 18.6 times 5, and that will give me the total perimeter, which, let's see, carry your 3 would be 43. Sorry about that. A little dyslexic there. 43 would be 93.0. Now I think their answer is 92.9. That's close enough. So 93. You know what I want to say to you, men, and ladies too. What I want to say to you is simply this. I'm not saying would have you thought to have done this on your own. That's not what I'm saying. I'm just saying, do you understand what I'm doing as I explain it? Because if you do that, then the next time I give you one of these, you can probably come close to doing it on your own. And the third time, you probably will be able to do it on your own. Okay? And yes, these word problems will be on your quiz on Friday, which I know I just totally made your evening. All right, number 27. Number 27 does not have a picture, so listen carefully. For a science fair project, a group of students tested different materials used for kites. Their instructor provided an instrument that would give them the angle of elevation. In one of the tests, the angle of elevation was 63.4 with 670 feet of string. Assuming the string was taut or super tight, how high was the kite? Now relax. First of all, we have an angle of elevation of 63.4. I've taught you what to do there. You know how to do angle of elevations. Here we go. You draw a horizontal line, and then angle of elevation means you go up in the air. So go up in the air. There. And just simply write in here 63.4. That was easy. Angle of elevation is a horizontal line with a line going up. It's that easy. Angle of depression is a horizontal line with a line coming down. It doesn't matter what direction. Mr. Earhart, I did this problem, but I did it like this. I put a line like this, and I went like this, and I put 63.4. No problem. It doesn't matter which way you have your slanted line going. It does not matter. So here's where I guess you're laying on the ground flying the kite. I don't know. Here's the kite up here. I'm the only one that laughs at my jokes. And now they're saying if the string right here is super tight, if the string is tight, you would have how many feet of string? 670 feet. So I know this string is 670 feet. Now, obviously, here's the height. The height of a kite is how high off the ground it is. So that's going to be a 90-degree angle right there. At least it should be. So that's what you're looking for, the height. Well, that's not bad. Here's your angle. What are these two sides called? This is called your opposite side. This is called your hypotenuse. What trig function uses opposite and hypotenuse? Good. Nice answer. Sine. So the sine of 63.4 equals opposite over hypotenuse. Now multiply both sides by 670, and you would have 670 sine of 63.4 degrees. And over here you would just have x, because your 670s would cancel. Now if you type that whole thing into your calculator, and we're on what number? Number 27. Let me find my notes. I have that done. If you would type that into your calculator, you will get 599 feet, which is the answer. So 599 feet is how high the kite is. So now you know the height of the kite. 599 feet. And I told you to skip 29. There's a reason. I don't think it was any harder than the other difficult problem we did. I just feel like it was just really, really long and unnecessary. So that's why we skipped it. That's the only reason. Number 31. The pitch of the roof of a medical office is 5 to 12. Now let's stop right there. I want to teach you something. You know what that 5 to 12 means? It means rise over run. Oh, sound interesting, guys? Slope. Okay, let's continue on. If the building is 33 feet wide, how long must the rafters be? Now, I'm going to warn you right now, I am not a drawer. In fact, I'm the antithesis of a drawer, okay? But I will try to do a little bit of drawing, okay? I'm sure you'll enjoy this, and that's fine. You can laugh at me, and my own children do. My own wife does. So that's fine. So we'll go up and then down like that, and then we're going to grab this and pull this over here, get it out of my excellent drawing way, and let's see, here we go. All right, now, this is good enough for you to see. Now watch what I do here, okay? You can just kind of watch. You don't have to write all this down. When they say the house is this wide, and let me take a look at the problem. I was on a different page there. When it says the building is 33 feet wide, here's what that means. It means 33 all the way across. Got it? 33 feet all the way across. Now, what they're saying is the pitch. Now watch how we figure the pitch. Are you ready? Draw a right triangle right here. And when they say what's the length of a rafter, I knew you probably didn't know all this, and that's fine. What they're saying is how long is this right here? This side slanted down right here. And this side slanted down. That's what you're trying to find. Now, this doesn't look like too hard of a problem, except herein does lie the problem. You understand if the width of the house, and now that I've drawn this, you might be able to finish it on your own. If the width of the house is 33 feet, cut that in half and you get 16.5. We know now that this triangle, this blue triangle, this side right here would be half, so 16.5. So you know you've got a right triangle that looks like this. It comes down, comes over, comes up. I drew it a little bigger there so we could see it. We know this is 16.5. And we know we're trying to find this. I already told you that. The problem, students, is we don't know this angle right here. And without that angle, we're in trouble. But I would like to submit to you that you do know the angle, or at least you can find the angle. Really, Mr. Earhart? Yeah. Remember how they told us we would have a rise over run 5/12? That's called the pitch of a roof. And I've roofed before. I've done, wow, it's amazing how badly I can draw things. I have done roofing. I've put a roof on. It's scary if the pitch is steep. And I am scared of heights. I don't like heights. But what this is saying is, I didn't draw this to scale very well at all, so please understand that. But what they're saying when they say rise over run is they're just simply saying, I'm going to shrink it down a little, that the rise is 5 and the run is 12. Now, it doesn't mean that doesn't mean we have 5 and 12. You can see we have a 16.5 right here, right? But what that is that's the model or the ratio of the rafters. So using 5 and 12, I can find this angle. And then once I find that angle, I can bring it right over here and put it in this triangle. This is not super easy, but that is how you would do it. So based on this angle, we have opposite and adjacent. So tangent of theta equals opposite over adjacent. Now, are we missing a part of our fraction? No. Are we missing an angle? Yes. So you hit second tangent, and up pops your -1 with the parentheses. Then you type in 5 divided by 12 and hit enter. And if you do that, you will get theta equals 22.6. So now I know what angle I can put in here. Now I know I can put 22.6 degrees. So now I can finally solve for x. I can't? Yeah, sure you can. Here's your angle. So we go straight across. This is your opposite side. This is your hypotenuse. And this is your adjacent. We're trying to find x, so we know we have to use hypotenuse. We know we want to have a known side, so we want to use adjacent because we know it's 16.5. So what trig function uses adjacent and hypotenuse? Well, that's going to be cosine. So cosine of 22.6 equals adjacent 16.5 over hypotenuse. And now we should know multiply both sides by h. And when you do, you get h cosine 22.6 equals 16.5. And then divide both sides by cosine of 22.6. So I'm not sure why I put x. Actually, I probably should have used x. That's what I had right there, didn't I? Well, it's too late now, sorry. But h equals, or x, whatever, 16.5 over cosine of 22.6. And if you type that into your calculator, 16.5 divided by cosine of 22.6, you will get, students, 17.9. So this rafter right here is 17.9 feet. Now, you talk about practical math. When am I ever going to use this math again? Well, you just saw it right there. That's a construction worker's problem right there. You got to find how long you want that rafter to be. You know you want the pitch to be 5 over 12, which that gives you the angle. So now you know you want what angle there, 22.6. But then you got to know if you got 16.5, how long do you want the rafter to be? Well, 17.9. Very practical problem. All right, number 33. Number 33, they do not give us a picture. So let's see what we can do here. From a hot air balloon, the angles, this is a pretty tough problem. This is the one I was talking about before, so please pay close attention. From a hot air balloon 2 kilometers high, the angles of depression to 2 towns in line with the balloon are those 2 angles. How far apart are the towns? Now please listen to me. Let me help you, okay? And I really feel like if you'll let me help you here, you can understand this problem. First of all, here's your hot air balloon up in the air. Don't try to get all fancy and use, draw the balloon. Just put a dot. Here's the ground down here. Okay. We're going to say one town is here and one town is here. I don't care if it's drawn to scale. I'm not worried about that. Now, it says the balloon is 2 kilometers high. So I'm going to go ahead and draw this line, and I'm going to call it 2 kilometers. So the balloon's 2 kilometers high. Now, would you please look at the problem, students? Look at the second line in the problem. Angles of depression. Angles of depression. Now, I know you're feeling pretty depressed right now doing these problems, but that's not what it's talking about. Angles of depression means you have to draw a horizontal line. Wow. If you would use a mimeopad, you would see it is so hard to draw on this thing. It really is. Remember, I've taught you to draw your horizontal line and then draw your lines going down. Okay, so there's your line to one town, and we're actually going to grab that and do a little better job of lining that up. There we go. And then here's my other one. Wow. Going down right here. All right. Now, again, this is hard, but if you'll pay attention, I will help you. Angles of depression. Remember, you draw a line, horizontal, draw a line, and the angle always goes from the horizontal line to the other line. From the horizontal line to the other line, remember? So, angle of depression. Here's my horizontal line. I've got one angle of depression that goes like this, all the way to that line. And I've got another angle of depression that goes from here to that line. Now, which one of your angles is smaller? 13.5. So we're going to go ahead and we're going to put 13.5 right here. Okay, students? Now, this whole angle from here to here, that whole angle there is supposed to be 81.2. So that means if I take this angle here with one dot and this angle here with two dots and add them together, this whole angle should be 81.2. So what I did is I did a little subtraction. I just said, okay, if the whole angle from here, let me go back. If the whole angle from here to here is 81.2 and this much is 13.5, then this has to be 67.7. Now, how did I get that? If you add those two angles together right there, you will get 81.2, which you're supposed to. Okay? Now, while I was doing all this brilliant math, if I do say so myself, I said, this is a right angle right here. From here to here, that's a right angle. So that means if I take this angle and this angle and this angle and add all three of these angles up, I should get 90. So I said to myself, okay, add these two up, subtract from 90. This angle right here has to be 8.8. Now I can sense your frustration. I wouldn't have thought to have done it. That's fine. You're not supposed to. You're just getting started. Contain your excitement. We'll do tons of these, okay? But are you understanding what I'm saying? These three angles had to add up to 90. So I'm just kind of filling everything in. Now, let's see here. They tell us that we're trying to find the distance between the two cities. So I'm trying to find the distance from here to here, and I'm going to call that x. Okay? So from there to there is x. Very good. Now, you say, well, Mr. Earhart, you don't know the distance from here to here. You're right, I don't. I'm glad you said that, but I can find it real quick, and I'm going to. I'm going to take my blue marker here, and I'm going to trace over this triangle. So we're going to go from here and back to here and to there. And I'm going to grab it and I'm going to pull it out of the way. There. Now why did I do that? Well, watch. Because I know this angle here is 8.8. I know this has a height of 2. And now I can find this little distance right here. We'll call it y, since I already have x right here. Now here's my angle. So this is called the opposite side, and this is called the adjacent side. So I would say tangent of 8.8 equals opposite over adjacent. Multiply both sides by 2, and I would have 2 tangent 8.8 equals opposite. And if you type 2 tangent 8.8 into your calculator, you get a really weird length, but it's 0.31 is your opposite side. So now I can label this opposite side right here 0.31. So this side right here, I now know this distance is 0.31 from there to there. Well, Mr. Earhart, is that really necessary? Yeah, you're going to see in a second. That's amazingly necessary, what I just did. You definitely need that. Now, and this should be in your notes. Hopefully, I'm going to take it away because it's already in your notes, I hope. So I'm going to get rid of this. Now, now what I want to do, I'm going to show you something about this big triangle. Now watch this. Remember, our goal is to solve for x. Don't lose sight of the trees for the forest. Our goal is to solve for x. So watch this. I can highlight this big triangle here, this big right triangle, like that. And now I'm going to pull it down like this. And now watch what I do. Watch this carefully. I've got a point here and a point here and a right angle here, and we know from here to here it's 0.31, and from here to here we're calling that x. Now, do I know this whole angle right here? Well, let's see. Wouldn't it be this whole angle right here? So if I take 67.7 plus 8.8 for that big triangle, I'm going to get 76.5. So I do know this angle. It's 76.5. I'm doing really well. Oh, and by the way, isn't this height here the same as this height here? Sure it is. So now I know this is a height of 2. Is that helping a whole lot, Mr. Earhart? I think so, definitely. I mean, watch what I can do now that I know, now that I've got this big triangle. Don't want that. Now that I've got this big triangle here that I'm totally messing up. That's going to help quite a bit. Watch what I can do now. Okay, here's my angle. So this whole side here is my opposite. This is my adjacent side. So I can say tangent of 76.5 equals opposite, which is x plus 0.31, right? I mean, think about it. It's this whole side, and part of the length is x, and part of the length is 0.31. So if I add those two together, I have the whole side, opposite over adjacent, all over 2. Now multiply both sides by 2, and I have 2 tangent 76.5 degrees equals x plus 0.31, right? Now type this into your calculator, 2 tangent 76.5, and if you do that correctly, 2 tangent of 76.5, you'll get 8.3306. 8.3306 equals x plus 0.31, and now subtract 0.31 from both sides, and you will get 8.02 for x. So 8.02 equals x. Now, that's x? Sure it is. So that's the distance from here to here. Does that help a whole lot? I think so. Remember, that's the distance from here to here. And didn't I say these were my two cities right here? Yes. And what does the problem say to do in number 33? It says find. It says how far apart are the distances? Excuse me, are the cities. And so that is how you would do that, okay? All right, moving on to number 35. Number 35. And we're getting close to being done here. And then we're going to do number 37, and we are finished. All right, number 35. In extreme large forests, it is not cost effective to position forest rangers in towers or to use small aircrafts to continue to watch for fires. It's just too large of a forest. Since lightning is a frequent cause of fire, lightning detectors are now commonly used instead. These devices not only give a bearing on the location, but also measures the intensity of the lightning. A detector at point Q is 15 miles west of a fire station. So I can draw that. That's pretty easy to draw. So here's Q right here, and it's 15 miles west of a fire station over here. And I think they said the fire station, we're going to call that R, point R. So here's point Q. That's where the detection device is. Here's R, the fire station, and they said the distance is 15 miles. So, guys, that's pretty simple, not too hard, okay? Now, let's read on. The bearing from Q to where lightning hits due south of R. So we have lightning that hits due south. So I'm going to go straight down from R right here, and I'm going to put lightning. It says lightning strikes. Sorry for changing colors. No significance there at all to the problem. Okay, so lightning strikes down here at this point. So I'm going to go ahead and draw this straight down. Now, it says the bearing from Q is south. So what I teach you to do, you draw an imaginary line going south. Remember, I taught you that yesterday. The first word is south, so I draw a line going south from Q. Why from point Q, Mr. Earhart? Because it says, the third line from the bottom, the bearing from Q to where the lightning hits is south 37.6 degrees east. So I go south, then I rotate east, and then I want my line to go like this and to hit there. Of course, not the best, but there we go. And now I know this angle from here to here is supposed to be 37.6. And now the only question they're asking is this: how far is the lightning from the forest station here? Now look, guys, I have a right triangle because it said I went due west and due south. So I've got a right triangle. But the problem is I don't know any angles inside the triangle. Maybe I do. Hey, look, this was due south here and due west here. So that means I've got a right angle right here. Do you see that? That's a right angle. So if I have a right angle, that means this angle here with one dot plus this angle here with two dots has to add up to 90. So if I take 90 and subtract 37.6, what I'm going to get is 52.4 for this angle here. Now we're talking. Now I've got an angle inside my right triangle, so I go straight across. That's my opposite side. Here's my right angle, so I go, this is my hypotenuse, and 15 is my adjacent. Now, I'm trying to find x, so I don't need the hypotenuse at all. I need to have a known side adjacent, so I'm going to use opposite and adjacent. Well, we should know by now, opposite and adjacent requires tangent. So tangent of my angle inside the triangle, 52.4, equals opposite, which is x, over adjacent, which is 15. Now we're going to multiply both sides by 15. That'll be 15 tangent 52.4 equals x. And now if you type that in your calculator, 15 tangent of 52.4, you will get 19.5 for x. And of course that's miles. And how do I know that? Because 15 was in miles. So whenever we solve for x, it will be miles. So the distance from R down to where the lightning struck is 19.5 miles. And that could be a real big help to a ranger if he's trying to figure how far, if he knows how far a city is from here, then he knows how far the fire is from a city if there's a big forest fire. So this is very practical. Last but not least, number 37 reads as follows. A lobster boat is situated due west of a lighthouse. A barge is 12 kilometers south. From the barge, the bearing to the lighthouse is north 63 degrees 20 minutes east. How far is the lobster boat from the lighthouse? Now, before we go any further, would you please listen? This is the lobster boat right here. So if you didn't know that, and I know it's kind of hard to see from the picture, now you know. All right? So that's the lobster boat. So when it says how far is the lobster boat from the lighthouse, that's the length we're trying to find right there. Got it? Okay. Now let's do our usual. Let's do our usual of copying the triangle and then pulling the picture out of the way. So there's the triangle they give us. You can see that in the book. Now let's pull this out of the way and let's label everything nicely here. We know this has a length of 12. We know this is our right angle. This is 63. Now I went ahead and converted 63 degrees and 20 minutes to decimals. That'd be 63.3 repeating, or just 63.3. And I think that's all they give us. We know we're looking for this right here. And boy, this might be the easiest problem out of the whole day, so at least they ended with a really easy one, and they're being nice to us because we want to find x. Here's my angle, so I need these two sides. Well, this is called the opposite side. This is called the hypotenuse side. This is called the adjacent. So I need to use opposite and adjacent. Opposite and adjacent. So the only trig function that uses opposite and adjacent would be tangent of 63.3 degrees equals opposite, which is x, over adjacent, which is 12. Now multiply both sides by 12, and you would have 12 tangent 63.3 equals x. And let me glance at my notes real quick. If you type that in correctly, I'm getting 24 for the answer. 24. Now what was 12? Was it kilometers? Yeah. 12 right here is kilometers. So that means my 24 is kilometers. So how far is this boat right here from the lighthouse over here? 24 kilometers. A rough video. You've been troopers. Thanks for listening. I hope this is helping you. Please work hard. Please call me with questions or email me. I will help you if you'll do that.